And this is what we're going to call, it's under triangles. And the little subheading under triangles would be special right triangles. Why do you think they call it that? Anybody? Madison, why do you think the book calls these special right triangles?
They're special?
Yes, that's exactly what I was going to say. They call them special right triangles because they are special. And there are two of them. There will be two of them. This is one of them. One of them is, by the way, they're called right triangles. Madison, why would they be called right triangles? Exactly. One of the two special right triangles is what we call a 30, 60, 90 triangle. Chase, why do you think it's called a 30, 60, 90 triangle?
Because it's special.
Fish, why is it called a 30, 60, 90 triangle?
Because that's the triangle's measurement.
That's the angles in the triangle. A 30-degree angle, a 60-degree angle, a 90-degree angle. Tell me if that's over your heads. Anybody? Is that too steep for you? Now remember, ladies and gentlemen, and kids of all ages, there are an infinite amount of 30, 60, 90 triangles. Okay? I could draw a 30, 60, 90 triangle that looks like this. You know, I could draw it like this. Okay, it could be any size. They'll all fit into this little category here. Now, well, should I give you the other special triangle, or should we go into it? No, let's give the other. The other special triangle is what's called a I don't know what do they call it? It's got 45 hands, but did they call it a 45? Yeah, a 45, 45, 90 triangle. I hate to even ask this, but, John, why do you suppose it's called the 45, 45, 90 triangle? That's what its angles are. By the way, what type of triangle is this? If you were classifying this by its sides, this is a, oh boy. You ever wake up and feel that you're a failure? Joseph?
Isosceles?
It is isosceles. Why is it isosceles? Because if you have two equal angles, you have two equal sides, and this is an isosceles triangle. Okay? So, you're asking yourself, what is going to be the point of all this?
What is the point of all of
I'm going to ask you that same thing. Okay? Here we go. Now, work with me, just think with me for just a moment here. Let's say I made this triangle, I doubled it and made this another triangle using this same side as this. Made this a 30, this a 60. So now I have a 60, 60, 60 triangle. Let's just say I doubled that. Just for fun, I'm doing that. Just for fun. What type of new triangle did I construct here? Anybody? A triangle that has all 60-degree sides on it, it's called a, huh? Anyway, just take a guess. You're wrong usually half the time anyway, so never guess wrong. Yeah, this new triangle here in yellow is an equilateral triangle. Wait, what's so funny about that? I'm writing it in yellow because it's really not that important. It's kind of like you have to pick it, you have to think it as being a ghost. Is that better? Equilateral triangle. Okay. Here's where things get a little bit on the dicey side. All right, this is the whole point of such thing. Do you see this side here? Just say yes because you must see it. It's orange. Okay. All three sides are equal, right?
Yes.
Yes. If you look at this side of the orange thing, what fraction of that side would this orange side be? Look at it. This and this are the same. This is the same as the orange side. So this side has to be what fraction of that side, John? Half. So, Madison, while you're looking blankly and staring at me with that questioning look, I am just going to, out of the blue, I'm going to say that I'm going to make this side 2. I just picked that number because I like 2's. I like 2 2's. Not 2 2's. So Madison, you questioning me on that look. If this side is 2 and this side is half of that, what would this side have to be? 1. How about that? So we've got a 1 and a 2. Now if I know this is 1 and a 2, I can figure out what this side is, yes? Because is it my Pythagorean theorem, is there a 1 2 or a 2 1? No, there's not. So I'm going to use the Pythagorean theorem to figure it out. How about that? A squared plus b squared will equal c squared every time on a right triangle. My a squared is, let's just use 1 times 1. I don't know my b because that's the other leg. But I do know my c, which is 2 squared, right? If you don't get this, it's okay. You'll figure it out later. What's 2 times 2? Okay. If I subtract my 1 and solve for b, don't worry, you don't have to know this. I'm just helping you out for those of you someday. I get b squared equal to 3. In which case b equals what? Anybody? Somebody. We talked about this before. B squared equals 3. It's an irrational number. It doesn't work out, but I do call it what? My kingdom for a horse. Fish. If b squared equals 3, what does b equal? Madison. No, that doesn't work out evenly. You're not going to tell me it's 1.765431, whatever it is. You're going to tell me, Olivia,
The square root is 3.
thank you, we've got somebody. If b squared equals 3, then b equals the square root of 3. We don't know what that, I mean, we do know what it is. It's some long decimal number. So this is the square root of 3. Now, ladies and gentlemen, here we go. Ready? I'm about to take you on the proverbial ride of your life. Chase is still looking at this. This right here, children, for this part of the show, I'm going to redraw it here. I'm going to redraw this same triangle up here without all that gobbledygook there so you can see this. In my 90, 30, 60 triangle, this side was 2, this side was 1, and this side was what? Help me out here. Somebody besides 2 people. Everybody. Okay. Here is what you need to come away with on this. Every single 30, 60, 90 triangle will have those same proportions to it. Let me say that again backwards. 90, 30, 60 proportions will have. All right, that means this, and I know you're looking at me kind of goofy here. If I draw another 30, 60, 90 triangle that is like bigger, okay, and let's say this side is 3. The proportions of this side will be the exact same proportions as this side, and you just have to think how they relate. To go from 1 to 2, I just double it. So on my new triangle, if this side happens to be 3, the hypotenuse is always going to be double 3. If this side was 7, this would be 14. If it was 10, it'd be 20. If it was 100, it'd be 200, whatever. And the third side, the other leg, the middle leg, here it gets a little strange, but to go from 1 to the square root of 3, you just multiply by the square root of 3. So if this is 3, this side down here is 3 square roots of 3. Whatever this side is, this side you just tack a square root of 3 after it. This side is always double that side. This side, all right, you're saying what? Give me a break here. All right, let me give you another one here. Let me change it. Now this is not proportion, but if this side was 50, if I know the hypotenuse, I can figure out the other two sides because it's always in proportion to this is my base triangle. This is my starting point. This is the one that I do everything from. What is this side? If this is 50, this side is always half of that, so this side would be, and this side is always this short side with a square root of 3 after it. It's 25 times the square root of 3. You just always think of this base triangle, and you can manipulate the numbers however you want with that. Let me give you one. How about this one? Let's say this is 70 square roots of 3. I gave you an easy one just because. How long is this side? Wazam, tell me. 70. Because it's whatever number's in front of the square root of 3. And then how long, ME, is this side? If I know the hypotenuse is always double this side has to be thank you, 140. 140. Let's do another one. What if it was this one? Oh wait, let's, in case this is messing you up. What if it was this one? And this was 16 times the square root of 3. What are my other two sides going to be? Remember, this is not for every right triangle. This is a special triangle, as are most of you. 30, 60, 90. It has to be that proportion. By the way, are any of you do you ever think you might want some sort of a degree in engineering? Ever think about engineering as a thing? All right. If you think about engineering, you'll at some point have to take a drafting class where you have to draw pictures and do all this technical drawing stuff. They will give you 2 triangles to work with, like ones that you draw a triangle line group. One of them will be this one. You will have a 30, 60, 90 triangle because it is the most common thing. And you'll also have that 45 one we're going to talk about next. So these are important. Anyways, back to this. 16 square roots of 3. What is my short side, Sophia?
Oh, it's 16.
It is 16. What's my long side? My hypotenuse is, Cassie? So, am I talking down to you now? Is this getting, should I do 8 more examples? Or do you think you probably got that one? I thought you probably would. So,
Do we still have to write the coordinate for the exam on our page?
not if it's a special right, 30, 60, 90 one. You just have to give me the numbers. You should know what it is. I mean, now, maybe or maybe not, you'll be able to figure out what we're going to do on this one over here. Using the same, hold on a second, I feel maybe if this was blown up a little larger, it would help you. If you're talking about a 45, usually we just go with a 45 right now. I don't know what we're going to do. Let's do the same thing. If I double this and this, wait, can I do that? I can't make a 45 there, can I? Because if it's a 45, it's a 90. Oh yeah, I could. Could I? Sure.
Yeah.
This is my right angle right here. I can make that 45. Sure, why not? It don't matter. Let's take that away. I don't need that. That'll just confuse you more than or less than you already are. Let's just go back to the triangle we already know. We already know that this is an isosceles triangle, right? So I'm going to pick some numbers here. I'll make them easy. I'm going to pick, I don't want that. I'm going to pick this to be 1. I need a 1 there. If this is an isosceles triangle and this side is 1, how long is this side? What? Let me refer. What's an isosceles mean? The two sides are equal?
Yeah.
So if this is 1, this side is
1.
1. No, it's not. This is the hypotenuse right here, children. That one's going to be the longest side. Now, using the Pythagorean Theorem for this one, which is going to be pretty simple, I hope, a squared plus b squared equals c squared. My legs are both 1, so 1 squared plus 1 squared equals c squared. 1 times 1 is 1, plus 1 times 1 is 1, which is c squared. 1 plus 1. 2 equals c squared. Let's just boil down to that. So c equals
2 and 4.
2 does not have a perfect square. It's an irrational number again, just like the other one, but it is the square root of 2. Square root of 2. So with a 45, 45, 90 triangle, here is your ratios. This side and this side are the same. This side is whatever these sides are times the square root of 2. Somebody says. So here we go. Here's my triangle. I'm going to draw it like this. This is my 45, 45, 90. If this side is 7, you can tell me the other two sides. What is this side? 7. And what is this side? 7 square roots of 2. It's just the square root of 2 added onto those two sides right there. So if this was, does that look like a 45? 45, 45. Ooh. What if this was 1/2? What are the other two sides going to be? What's this side going to be? 1/2. And what's this side going to be? 1/2 square roots of 2. It's a pretty cut and dried sort of simple sort of thing. Wait, we're not done yet. That's not even close. What do you think? How about this? What if this was 1,003 square roots of 2? What are the other two sides? I know it's hard. No, don't, Madison, you might think about your answer. Do not answer hastily. All right, Madison. I'm sorry, what? 1,003 would be the other two sides. Because they're just whatever numbers in front of the square root of 2. By the way, what number would be close to 1,003 square roots of 2?
100.
That's a good guess, but doesn't seem right. Do we ever write down what the square root of 2 should be close to? What is the approximation? The square root of 2 is approximately, by the way, in math when you want to say approximately, you draw that little squiggly equal sign because it's not really equal to, but it's as close as we need to get. Somebody, do we not write down the square root of 2 somewhere under irrational numbers? Somebody grab your irrational notes and see, I thought I gave you the square root of 2 and the square root of 3. 1 point something. 212, 313, 618. Square root of 2 is close to? Say it aloud, Grace!
1.414.
Is it? That's the square root of 2? 1.414. You sure?
Yeah.
That's not the square root of 3?
No, square root of 3 is 1.732.
Oh, let's write that down. Square root of 3 is approximately 1.7 what? 32. Again, that is not exact. It's only close because if you put it in a calculator, it goes on forever. So, Zachary, I'm going to go back to, wait, somebody, who said my 1,003 times the square root of 2 is actually, if you were guessing, it would be more like, okay, I'm guessing. Thousands, you said like 500 or 200 or something.
I said 100.
Yeah, that's a little low because it was just 1 times that would be itself. Flossie, what's a good guess for 1.414 times 1,003? Just spitball me here. Anything, Flossie. Give me something to work with. Does anybody think they have I mean, I'm not looking for an exact answer. I'm just like, well, I think it would be this because of what reason. Come on, where's my scholastic bowl, people? Somebody, if they give you the square root of 1,003 times the square root of 2 is close to what? Well, I'm going to force you to write down an answer. Chase, give me, what do you think? Could I just, what if it was 1,000 times 1.4? What would that be close to? Move the decimal 3 places, people. 1.4, move the decimal 3 places. Cassie? You really have nothing? Joseph?
1,414.
Yeah, why not? I'd go with that, 1,414. If you move the decimal 3 places, then you got another 3 over there. So I'd go with 420 maybe? Fish, what were you going with? Let's do that, by the way. Let's just do it because you can see if we're actually, I hate to just, the square root of 2, can I do that here? 2 square root of times, wait, did you say that?
Wait, the square root of 2? I already have that.
Didn't I say that?
6.
Wait, times what?
Six.
1,003. And what was I saying it should be? Joseph said, well, if it was times 1,000, it'd be 1,414. And I said, well, then you got 3 more of these, right? So 3 times that would be 5.2. I said it should be close to 1,420. I need a drum roll. It's not. 1,418. I guess that's close. I was thinking it'd be more like, why wouldn't it be more like 20? 3 times that. Oh, because 3 times that is, I was thinking, 3 times that is only 4.2. I was thinking 5.2. Well,